And now on to our first keynote talk for today. I'm delighted to have Professor Fei-Fei Li from Stanford University join us today. It is typical to have someone introduce the keynote speakers. And in Fei-Fei's case, I find that to be both hard and easy. It's hard because I will need her entire 1 hour slot, maybe more, to talk about all her achievements. Fei-Fei is currently serving as co-director of the Human Centered AI Institute at Stanford, having previously served as director of the Stanford AI Lab and also chief scientist of AI and ML at Google Cloud. She has had a huge impact on the field of AI broadly and computer vision in particular, where she made numerous contributions. It will probably be sufficient to just mention ImageNet, which changed how object recognition is done. But there are many other research projects that define new directions in computer vision, for instance, visual genome, ActivityNet, and many others. I'm also really admiring Fei-Fei for everything that she has done for diversity in AI through the AI for All program, which she co-founded and which spans now many institutions, including Michigan. I mentioned that introducing Fei-Fei is both hard and easy. It's easy because Fei-Fei doesn't really need an introduction. It's sufficient to say, here is Fei-Fei Li. So welcome, Fei-Fei. The screen is yours.
Thank you, Rada, and thank you, Michigan. Really an honor to be here. Let me just try to share my screen first. Thank you again. And I think when I was thinking about your introduction, I think the most important piece is that I feel like part of the Michigan family. I spent a sabbatical in Michigan in the early half of 2013. And just loved living in Ann Arbor, visiting Zingerman's and the North and Central campuses. It's just a gorgeous place. So too bad this is virtual, but I do feel very honored to be back to Michigan today and want to share with my colleagues some of these latest work we're doing in AI and healthcare. Before I just even get started, I want to show this slide to really drive home that this is quite a team effort. Everything I'm going to present is kind of a result of years and years of collaboration among computer science AI researchers, mainly my students and postdocs, as well as a number of incredible clinicians and clinical researchers throughout Stanford Medicine, as well as our partner hospitals and healthcare systems like Unlock, Utah's Intermountain, Stanford Children's Hospital, Stanford Adult Hospital, and the list is still ongoing. I especially want to highlight the two people in red boxes, Professor Arne Milstein, who is a pioneer in thinking about healthcare, this country's healthcare policy, healthcare excellence research and quality improvement, as well as cost reduction. I owe everything of my healthcare knowledge to Arne, who introduced me to this incredible field about 10 years ago. And then for this particular talk, I want to acknowledge my graduating PhD student, Albert Haag. He is one of the heroic AI students behind a lot of the work, as well as a main paper that I will be going over today. So without their work, I wouldn't be able to do this talk. So it's important for me to acknowledge them. So let's just get to the main talk. And we're here because most of us are passionate about healthcare. And in the past 100 years, modern medicine has gone through incredible advances, whether you look at drugs and vaccines, medical imaging, medical devices, genomics, you just name it. Our increasing life expectancy as well as quality owe a lot to the improvement of healthcare system. And also a personal note, I happen to have taken care of my mother, who has been very sick for almost 40 years, and all my entire adult life, I am the sole caretaker of my mom, and I've been through every single healthcare, environment, from ICUs to ERs to operating rooms to home care with her. And it gives me a personal perspective of how important healthcare is and what kind of incredible advances there has been, and how all of our livelihood owe it to modern medicine and its advance. But despite this important advances, it is still incredible to think in 2020 or 21st century, medical errors are still the third leading cause of death. And there has been extensive studies by NIH since 20 years ago, as well as researchers around the world that studies unintended medical errors. You know, in the healthcare delivery system, there have been a lot of important protocols written about how to avoid errors, how to execute in an intended way to both standardize but also keep the quality of care. But, you know, unintended errors still happen. In fact, there's way more, an order of magnitude and more death and fatalities caused by healthcare than, say, car accidents in United States annually. So this is a big issue. And why is it so? You know, why is the error rate so huge? Well, partially it's because healthcare is a very complex human behavioral uh, endeavor, and it takes place in very complex environment, and there are many different people and roles involved. And you know, errors can be introduced in so many ways, whether it's procedural or you know, incorrect coding or wrong prescription, or sometimes you know, hand hygiene compliance induced errors. Just so many ways that the errors can be introduced, and it's really not intended, but can have grave consequences. So at this point, for those of you who are in AI, especially in the broad area of AI and technology research, I hope it reminds you of another space that is full of complex human behavior. And that space is driving. And you know, Michigan is a leading university in autonomous driving technology, as well as robotics technology. So I think we have a lot of colleagues who appreciates how complex driving is, and a lot of driving's behavior boils down to complex human behavior and the potential errors or unintended problems with driving. So about 10 years ago, just around the time I met with Arnie Milstein, autonomous driving was one of the most exciting revolutionary ideas, and it was going from academia to commercialization, even though there's still a lot of research. What excites me as a technology about autonomous driving was the emergence of a bunch of technology that's enabling a whole new way of transportation: the sensor technology, the machine learning algorithm technology, the system integration technology, the GPS technology. All this is reimagining, helping us to reimagine autonomous driving. And that was the time that Arnie and I serendipitously got together and really made that intellectual connection between what we see in autonomous driving and the technology behind it, and what we hope to see in healthcare. That just similar to transportation, healthcare is a complex human behavior endeavor situated in very complex spaces, from hospitals to homes, that to a large extent, what's happening in these spaces with human behavior is still very much in the dark. We don't know much about what patient is going through unless we, you know, take their labs or stick them in some kind of imaging device. Or we don't know much about clinicians' behaviors unless they chart. And charting means documenting what they do on a electronic hospital record or medical record. But all this is actually affecting the outcome of healthcare. So what we kind of boldly envisioned is endowing healthcare space with the kind of ambient intelligence we see in smart cars, and with smart sensors and machine learning algorithm, and transform this so-called dark space of healthcare into a visible and visualizable space that we can really try to help improve the outcome of patient care. And roughly speaking, the transformation of this physical space involves enabling it with sensors. And I'll get into the details of what kind of sensors we're talking about. And then, of course, for those of you who are deep in machine learning AI research, just data itself doesn't speak much much insight. So we have to go through machine learning, computer vision technology to recognize what's going on with human behavior. And then at the end, this shouldn't be a standalone technology. It should be integrated into the clinical data ecosystem. So that's the kind of broad picture we imagined. Fast forward almost a decade later, we just published a relatively comprehensive Nature Review article on what we have learned on this journey, as well as many incredible research that has concurrently happened in this short period of time. So for today, the rest of the talk will be just kind of a summary of what we touched in this Nature paper, especially two critical healthcare space. One is hospital space, one is daily living space. I'll go over briefly what are the potential opportunities to use ambient intelligence to improve the healthcare delivery. And also, Rada, please just tell me if I'm going to over time, because I do want to leave time for discussion. So thank you. So let's just start with healthcare space. In the paper, we actually touch on several hospital space, ICU, inpatient unit, operating rooms, and other clinical settings in the hospital. I'll try to quickly go through just two scenarios to give a flavor of what's happening and what we can use ambient intelligence for. So ICU is an important area of healthcare delivery. In fact, you know, I don't know if most people know this number. Almost 1% of our national GDP goes to ICUs alone, and the cost of ICU is in hundreds of billions of dollars every year. And in this COVID setting, we hear a lot of stories coming out of ICU that underscores the importance. And this is where our patients fight for their lives. This is where our clinicians are just by and large overworked. But yet the healthcare, what's happening in ICU is so critical to every single patient and their family. So in ICU setting, there was one project we participated and spearheaded, which is the patient mobilization project. It turns out if we can properly make patients move in ICUs in a proper way, evidences say they recover better. They get out of ICU faster and they recover from the grave situation better. So patient mobility is really important. How do we ensure patient mobility, and how do we know the quality and frequency of patient mobility is proper? By and large, right now, it's direct observation and nurses and clinicians charting. And this, you can see, introduces a lot of issues. Charting itself is erroneous, and it's also labor intensive. A lot of clinicians complain about spending more time charting than spending time caring for patients. And also charting is very brief. It doesn't have that nuances that we hope to see, and there's a lot of errors that can be introduced. So we worked with two hospitals, Utah's Intermountain and Stanford Children's Hospital, to put sensors into the patient rooms. And the orange dots you see are sensors in a floor map of a ICU unit in the Intermountain Hospital in Utah. And then what you see in the blue video is the quality of data we capture through a special kind of sensor called depth sensor. If you're not familiar with depth sensor, I hope to draw a connection between Xbox video games and the sensor. In fact, this is a LiDAR-based, it's an infrared based sensor that and that captures depth information in the environment. It does not capture RGB pixels. So it's actually naturally a good sensor to try to respect and protect privacy in a clinical setting. And it's obviously noisy. And what we can do is to take these videos and then use machine learning algorithms to learn what kind of human behavior has taken place. In this particular setting, for mobility, we care about activities such as getting patients out of bed, sitting patients in a chair, getting patients back to bed, getting patients out of chair. These are clinically relevant mobility tasks. And then we learn to label them by our AI algorithm behind the scene. And then what we can do is to start collecting data insights. We not only can in computer vision, it's technically called action detection in long videos rather than just action classification of an entire video. So we can get into this kind of action detection tasks where in say 24-hour stretch, we can collect data insights about how patients have been moved over that temporal stretch. And this is just to show you it's getting finer and finer, and we can actually identify the people and the hopefully in the future the roles and the actors. And this kind of quantitative data insights is the first step to provide a very continuous objective measure of patient mobility in ICU, which has never done before. It, as I said, it relied on clinician charting, which is extremely sparse. And the specificity and sensitivity of the quantitative results are really, really high, which really is important for our clinicians. And of course, in the ongoing work, we're going to extend this to more finer grained human activities, including turning oral care, putting on compression stockings to avoid pressure ulcers, and so on. And then we can tabulate these kind of data insights and provide clinicians the important data for our patients. So that was one ICU project. Another related ICU or inpatient project is hand hygiene. 8 years ago, we started a hand hygiene project, and frankly, not too many people cared. But when COVID-19 happens, hand hygiene compliance suddenly becomes such a front and center issue, not only in hospitals, but also in our homes. In fact, hospital-acquired infection is one of the leading killers of patients nationwide, not just during COVID, but just during entire healthcare times. And almost 100,000 patients die of hospital-acquired infection every year, 3 times more as car accidents. And so what have we been doing to ensure hospital hand hygiene compliance? Mostly through human observers or secret shoppers. As you can see, it's subject to so much issues, right? It's very sparse, it's time consuming, it's expensive, it's subject to human biases. People have tried RFID as a way to automate the system, but RFID is very coarse. It doesn't really observe human behavior. It's a proximity measure, and it also disrupts workflow if clinicians have to go to scan their badge. So again, we installed some sensors, in this case, again, in Utah's Intermountain Hospital and the Children's Hospital in Stanford. This is what the physical depth sensor looks like. And this is the kind of data we can collect. And you can see that clinicians stopping by before entering a patient room to perform hand hygiene protocol. And what we do is to take the video data and go and devise a convolutional neural network action detection algorithm to try to locate both temporally as well as spatially where the hand hygiene behavior to take place. There are some technical challenges that I'll just gloss over, including how to combine multi-sensor views, and this is a combination of tracking and tracking issue as well as recognition, and we have to find a common space to project our people in the video so that we can combine the multiple views across a large hospital or inpatient space. And here's the detection result that a person was about to enter the room, and the sensors and the algorithm behind shows when they do the hand hygiene or they don't, and so on. And then, of course, we can also collect big data analytics over time and over people. And this is invaluable insight for optimizing the location of hand hygiene dispensers for our clinicians. Of course, if you are familiar with this space, WHO says hand hygiene is not just about entering room, it's about 5 points of 5 moments of interacting with patients before touching patients, before touching patient bed and all that. So again, without belaboring this system, I just want to say that we're doing additional research on the 5 moments that WHO has protocoled of hand hygiene that gets into the finer understanding of hand hygiene compliance. And this is some preliminary work to show in the patient room where, you know, potential touch points happens and how people are behaving. So that was a quick overview of ICU. I'll just quickly go to the operating room and try to speed up. Operating room, again, very complex environment, very complex human behavior. There are a number of work done by other groups that are already looking at ambient sensors. This is a group that are looking at human 3D pose in a surgical environment in the hope of training and tracking surgical staff. And let me just fast forward this. But in addition to people, people also interact with objects, and objects is actually a big deal, tracking them and knowing where they are in surgery room. And some objects can be tracked by RFID and barcodes, but many objects cannot. And these are the objects that are actually are more prone to errors, including getting lost in the patient body. So, you know, nurses have to spend a lot of time counting them, and at the station next to the patient. And we have started to pilot an idea of using depth sensors and cameras to help automate this counting process. I'm gonna warn the audience of the next slide. It doesn't have blood, but it does have real life surgery. So if you're squeamish about it, here's the warning. Okay, in another work in working with surgeons, we actually go into the laparoscopic videos and try to track surgical instruments inside the body, and by tracking that, we can learn. Oh, sorry, this is just the algorithm system flow. We can learn how the usage of different surgical objects. This is actually critical information. Keep in mind, this has never ever been observed without this technology. Surgeons just train through human apprenticeship and go through this you know, more like an artful training rather than objective training. And this is very good quantitative information for surgeons in training, as well as for surgeons to understand what happens and what are the instruments used in a surgery. So this is also ongoing research. Okay, so I'm gonna switch gear and quickly go through the daily living space The paper has more details about hospitals. I'll just invite everybody to read on your own. Daily living space is another space that has a lot of implication to our healthcare and well-being. I'm personally passionate about senior care, but also physical rehabilitation, mental health are all important part of daily living space. Just to get into senior care, independent living is really, really important to our seniors, and independent living involves activities of daily living, and there is a standard list of what we call ADL. ADL impairments indicates a lot of potential diseases and decline, cognitive, neurological, and other ones. And it has tremendous physical as well as physical mental implications. And typically, caregivers are the first to identify impairments, but we do have a global dilemma coming up, is that our population is aging. The ratio of caregiver to seniors is declining. We have fewer and fewer capable caregivers compared to the number of seniors, and this industry in general has other issues that is not well established, and we need to help our caregivers. One way to help our caregivers is to go through smart sensors and ambient intelligence. There is no way, I want to say upfront, we do not believe in replacing clinicians and caregivers, but we really believe in helping them and helping our seniors. Wearables is actually a good supplement, and there is a lot of good research coming up and commercialization. But there are a lot of issues wearables cannot address. It's inconvenient. Seniors don't necessarily wear them all the time. And when it comes to nuanced human activities, wearables are limited. So we're piloting this smart sensor ambient intelligence idea in a senior home facility in San Francisco. This is my heroic graduate students going to the senior homes, installing both depth and thermal sensors by themselves. And those of you who are not familiar with thermal sensors, you can see that on the right, it's thermal sensor data. On the left, it's depths. They capture quite complementary information, which is really useful for ADL understanding. And our algorithm can start to understand the behavior of seniors, whether they're sitting, standing, walking, sleeping, can do real-time detection of falls, which is extremely life costing and money costing in senior care. And then this is the kind of the opportunity we can put into important data analytics for different ADLs that can become really important clinically relevant data for our caretakers and clinicians. One of the example here to show you more fine-grained understanding is sleep pattern. We can actually, with this kind of technology, we can go through different kind of sleeps and sleep data on a daily basis. Okay, there's more in senior care. We are actually now starting a new project in 30-day readmission for seniors. It's been an exciting journey in the time of COVID, but we're excited this project will get started. But let me switch gears and just at least touch on physical rehabilitation, because I think this is so relevant to seniors as well, and to show you what this technology can do. Of course, everybody knows physical rehabilitation is so important. It's a big industry. It impacts a lot of people. Things like gait analysis is kind of bread and butter for many rehabilitation treatments. But most of these current physical rehabilitation is done in the labs, and patients have to get to the hospital, get to the clinics. It involves a lot of overheads, and it's also sometimes you have to use motion capture systems. It's very expensive and cumbersome. Can you imagine if there's just a camera at home that can start understanding the gestures, the gaits, the walking details of our patients, it'll really transform physical rehabilitation. And a lot of people are starting to pioneer that. In the paper, we cited a number of work in understanding human gesture, or using depth sensors to observe different kind of physical activities. And we are also doing gait understanding and human posture and pose understanding using depth sensors, and hopefully this can start enlightening the possibility of moving some of the physical rehabilitation to homes. These are just some quantitative results. Okay, so we also did some work in mental health, but I'm not going to have time to talk about this. In the last 2-3 minutes, I do want to touch on a really, really important aspect of ambient intelligence. It's its societal and ethical implications. At Stanford, we strongly believe in human-centered AI research, and a large part of this means that we have to take into consideration of ethics into the design of our technology, not as an afterthought. And this is where we work with a lot of bioethicists, legal scholars, philosophers, and actually ethicists who are experts in different angles of this problem. And we meet regularly with the computer science team and clinician team to discuss various issues. I'm not going to be able to go through all the details, but I will touch on categorically some of these issues. Privacy, of course, is a huge thing. There are technical ways to ensure privacy protection, including face blurring, including video downsampling, including human body masking. These are all examples. There are also ways to, make sure there's privacy in data on the data front, like differential privacy to add noise to individual record. In machine learning, we're exploring federated learning to so that data don't get centralized and can facilitate edge learning. We also are looking at homomorphic encryption. It's incredibly slow, but and how we can put stronger privacy guarantees. And there is also physical privacy of devices, from devices all the way to central servers. But of course, privacy goes beyond just technical solutions. There needs to be regulatory considerations. There are other issues in this research or this technology. Legal issue is another one. For example, this is just an example of psychotherapist patient privilege. But ambient sensors opens new challenges, like can the data become potential witnesses? And we are working with legal scholars, or at least providing our technical insight to legal scholars who are looking at these issues and hopefully forecasting and getting ahead in terms of thinking about laws. Of course, bias is a big issue, and fairness, and the world of AI has woken up to bias. There's bias introduced in data sets, for example, gender, skin color, and so on. There's also bias in the inclusion of different demographies. We care a lot about how to sample patients. And of course, regionally, we have bias. We have challenges, but at least we want to pay attention to these issues. I'm just going to, and then there is, algorithmic transparency, accountability. There are nice research has happened, such as model cards in the past couple of years that are useful tools to ensure algorithmic transparency and accountability. And of course, there is ethical issues in the scientific research itself, even before the mass application of this technology. And we are taking meticulous care into the different steps of our scientific research protocol, from IRB, human subject consent, all the way to data storage, data annotation, and so on. So I can spend days to talk about the ethical issue, but I think the overall message I want to deliver on the ethics front of AI research related to ambient intelligence is the importance of multi-stakeholder approach. From, again, bake the ethical design into the technology before a single line of code is written. And that's what we have been trying to do, to collaborate with policy leaders, ethicists, legal experts, clinicians, patients, and of course, technologists in this multi-stakeholder conversation. So that's all I want to share with everybody today. It's just a very superficial summary of what we feel so excited by, this new wave of ambient intelligence technology in AI and healthcare. And what I just want to say is, at the end of the day, healthcare is about humans caring for humans. AI is here to really help enhance humanity, not to replace. The many, many hours and days and weeks I sit in ICU or surgical room with my mother makes me realize how important and irreplaceable our caretakers, our clinicians, our nurses are. And our role as technologists is to make their work better, is to enhance their work, give their time back to the patients, and together to improve the healthcare system. Thank you so much. So I'm happy to take questions.
This is great, very insightful and very inspiring. And I see there are a number of questions. So there is one question about the multiple sensors being used. Specifically, the question talks about the ICU monitoring work. Is there a scope for multimodal data, for instance, including wearables or other devices that the nurses or doctors could use?
Yeah, I mean, as a technologist, absolutely. For those of you who are deeper in computer vision research, you can see that there is a really exciting new area of research integrating audios and videos recently. And here in clinical setting, I think multimodality does include wearables as well as potentially audios and depths and thermal. In fact, in neurological disorders, for example, early detection of stroke, let's say, I think audios is critical, right? So it depends on the situation, but short answer is absolutely.
There is also a question, again, with respect to the different sensors and different angles. You spoke earlier about the analogy between the medical space and the driving space. And so looking there is, for instance, LiDAR being considered as one option and cameras and another option. So if you could speak a little bit more, both about what do you think about these two different approaches with respect to, say, accuracy, but also with respect to privacy?
Yeah, a good question. I think it's probably pretty obvious to most of us that depth sensor and LiDAR, they're not completely privacy issue free, but they go a long way in protecting privacy because we don't need color information, we don't see faces, and so on. So from that point of view, we actually chose to use depth sensors since about 10 years ago because we feel it's just so much more respectful. But having said that, we shouldn't just pretend that there is no privacy issue. For example, gait identification is a way to identify people, and you can actually de-identify the person just through biological gait analysis, and that you can get that information from depth. And of course, if you're in people's home, whether you see the face or not, it's contextualized to identify individuals. So we have to be vigilant about that. But RGB camera, we have to go through a lot of good regulatory guardrails to ensure privacy is taken care of, and the patient consent and family consent. But I also want to say that there is value. There is a lot of clinical value in using camera information, because a lot of diseases and a lot of illness conditions, the signal comes through the colored pixels, whether it's nuanced movement patterns or facial expression of pain, or like I said earlier, early neurological condition detection, like face drooping in early stroke patient, in ambulatory or mobile medicine case. You want that quick detection, and pixel information is useful. So they're complementary. I would say I personally would try to push depth sensor as far as we can because of its advantage in privacy, but work with clinicians, patients, and policymakers to enable the possible use of cameras.
And that makes great sense. And I would follow up with a question that has been on my mind for a while with respect to ethical considerations, including privacy, which you touched upon. So there is this concern that if you account for personal information, there might be unethical issues being raised. But then if you look all the way through to the end application, I'm also hearing and from colleagues in healthcare that it would be also unethical to not help somebody who's in need. So I would be curious to hear your thoughts on this trade-off between the ethical considerations, say early on, in which kind of data to consider, and then really to the end application, like what kind of impact it could have or potentially would not have if we would stop working on this kind of applications.
Yeah, no, Rada, I think you touch on really important, even deeply philosophical point. And I think just by you talking to both clinicians and patients is the approach I would take. It's a multi-stakeholder approach. None of us, whether as an individual or as technologists, have the answer to all this, right? I wear the hat as a caretaker of my mother. And there are many moments, including now when I work from her remotely, I want technology to help me to give me more insights of how's her walking gesture today, how's her sleep pattern this week. And for me, that information is invaluable. Arnie, my amazing partner, always remind me and my team of technologists, let's not remember we're dealing with the most vulnerable, one of the most vulnerables of our population. And there are many ways we can help them. It's really hard to give a sweeping statement of what's ethical and what's not ethical when the forces of privacy, but also health and life are in play together. So the way I have been taking this is, first of all, be very respectful and humble about the space we work in. With my AI students, when they join the team, the first thing I ask them to do is to shadow doctors and to just feel the human empathy about the vulnerability of the population we work with. And to start there, take the multi-stakeholder approach, listen to patients, nurses, legal scholars. I feel confident given the brilliance of human minds and if the will of our collective, community, we'll find a good way to balance technology and human dignity and use necessary policy guardrails and technology smarts to solve these issues.
Thank you. And yeah, this is something that, like I said, I'm currently thinking a lot about, and I think it will require more thinking from many and balancing the sort of the trade-offs. There is another question regarding the work you talked about in senior care, whether there is concern that collecting data is infringing on autonomy, and how do these people feel about their independence? And I will also add my own follow-up to the question that was asked. To what extent will discourage people to try to be autonomous if there are all these systems that are helping them and partly doing their work for them?
Yeah, so really good question and several answers there. For scientific research, that's what we're doing. We're not building, monetizable products. For scientific research, I think patient consent and subject consent is a huge part of this process, right? Like we would only work with seniors who understand what this is about and who do not feel this is infringing on their autonomy or privacy and so on. And people are different. Not everybody is the same, and their own situation is different and they need different help. So at least we focus on working with the population that follows our human subject protocols. In terms of are they the deeper philosophical issue as machines start to kind of take responsibility of autonomy, what does that mean for humans? I think this ambient intelligence technology is pretty far from taking over autonomy because it's mostly an observing technology. It doesn't actually enact on behalf of people. It cannot take the pills for you. It cannot walk for you. It cannot exercise for you, right? It's more a way to gain healthcare insight, well-being insight. So for you, the patient, as well as for your caretakers, to try to help optimize the well-being. So from that point of view, this particular technology is not. I don't see a strong danger of taking over the sense of autonomy. And again, the bigger context, even at Stanford, we often talk about, I really, really believe there's so much more for AI to augment and enhance people rather than replace people, whether it's this particular healthcare we're talking about or manufacturing or other space. Of course, there are situations AI or robotics can replace people, especially safety, security situation. I would like robots to replace people in dangerous places. But by and large, this technology has more space to work on to enhance humanity. And that's another angle to think about this.
Yes, and I very much agree that that's where we can actually make a difference now. We'll have to see in the futures. And there, one thought I have, which will take me to the next question. I've actually thought about this augmentation in the context of my own children. At some point, I was thinking about how could I build technology that would help small children be understood, like really sort of translate their baby language into our language so they are understood. And eventually I gave up just because I figured that maybe that would not encourage them to learn the language that would help them communicate.
Yeah.
And there is a question which speaks about both age people, which you talked about, and then infant healthcare. And I would be curious to hear about your thoughts with respect to transfer learning. Are these algorithms that could be reused between different population, and what are your thoughts with respect to that?
Yeah, I actually think we have to use transfer learning. Few shot learning, long tail learning is a huge problem in healthcare, right? Like, for example, senior fall. How much data can you collect of real senior falling in their homes? First of all, I hope none. Second, these are rare events but have grave consequences, and there's no way. If you look at today's deep learning algorithm and how much supervision it needs, that we can collect enough data, at least not from our budget. and so I think domain adaptation, transfer learning, few shot learning, these are situations, these are learning methods that are so suitable for healthcare. I actually, my AI students, when we think about the technical contribution we can do, I think this is a huge area because almost every single health relevant activities we deal with is a long tail event. And hopefully they remain long tail event, and whether it's in the hospital or not, or at homes, these are long tail events. So we have to evoke these, the distribution disparity. You cannot hope for training data and testing inference time data to have the same distribution. So really good technical area to work in my opinion.
Thank you. And just one more question to wrap it up. There is a question on what do you think is the biggest bottleneck to introduce AI into healthcare domain right now? So there have been a lot of advances, as you highlighted. What do you think is the main bottleneck? Is it privacy, ethical consideration, legal?
Yeah, great question. I do think a lot about this. I think there's a couple of things that I just want to highlight. The first one is public trust. I think AI right now, as a member of the AI world, I'm concerned about AI's public image, and we can debate about whether we deserve that, but the image is not that great. Public trust is very low about AI and the technology in large. Think about the issues of bias. There's a lot of public outcry. Think about privacy issues. So I think working in healthcare, I personally care a lot about gaining that trust in the community and in the multi-stakeholder community that we work with. And I think as a field, collectively, we need to work very hard to gain public trust. And this is not just a PR issue. It's really about how we conduct our research and how we help to move the technological, or combine the technological aspiration with the goal of doing AI for good. So that's one issue. The second issue is actually modernize our policy and regulatory measures. I think it's really important that we work with regulatory agencies to modernize some of the guardrails and policies surrounding data, machine learning. On one hand, it's comforting to know healthcare is a highly regularized industry, and for good reasons. And as a patient or patient family, I appreciate that very much. On the other hand, technology has moved ahead. For example, data siloing and data sharing is a big issue in healthcare research. And can we modernize our regulatory measures so that while we keep the protection of our patient health record and data, but we also incentivize innovation, I think. And that also will help public trust. If we have the right policy measures and guardrails, we could hope to innovate within the safe boundary of trustworthiness. And that's also very important. So these are the two issues that at least rise to the top of my mind.
Well, thank you. And thanks again for a very insightful talk and for a great discussion. Thank you to everyone in the audience for your questions. And I will now hand it over to my colleague and collaborator, Professor Larry Ann, who will chair the next